ideas and expand on possibilities. I am your host, Malavika, and today we are tuned into a new edition of Tech Talk series, AI Uncovered, where we dive deep into technologies that shape our tomorrow. Today, we are venturing into a fast evolving world of artificial intelligence, and we have someone who lives and breathes this domain, specifically speaking. So, we have Srihari K, who is an AI enthusiast and developer here at TA. Srihari, welcome to the show. Welcome to TA Tech Series.
Thank you for the introduction.
Today, in this series, this is a series for developers, a team leader, or someone who is AI curious. I'm pretty much sure in this series you may get that you are looking for as an AI enthusiast. I welcome all my audience to this show. Welcome to TA Tech Series. Could you explain what a multimodal or how a multimodal AI works and how its integration with text, images, everything happens? So how is that and how that works? Could you explain that?
Okay, so when talking about multimodal AI, so the traditional AI or large language model just take only text as input and give back text as output. So the multimodal AI is actually taking input from text or images, videos, audios. There are multiple input, the multiple modalities or multiple input that can be accepted and process all those information, give back output as images or audios or text. Any type of output can be generated. So that's actually multimodal AI. So this is actually a combination of large language models along with the other modalities. Like for example, if you want to generate an audio, it will generate audio. If you want to generate an image, it can generate an image. It can generate a text, it can generate an output text. So any type of input will accept and any type of output that can be generated. So that's actually multimodal AI.
Okay, so this is how you think the integration with text and images help and
exactly
works.
Yes. Because the previously OpenAI or any other generative AI based company generated only large language models, only processing text. But then, for example, they first introduced the GPT 3.5 models. So in that models, only large language models is processing. Only the text is processing actually. So then they came up with the GPT 4o, which is actually a multimodal. They can process input text or images at the same time, and it will understand images and text at the same time, and it will process the generated output. So that the output will be images or the output will be text. So any type of input that will accept. Currently they also accept audios and they can also generate output as audio also.
One of the common words now we hear is something like RAG, retrieval augmented generation. So could you explain what is RAG and how does it enhance the performance of these large language models?
Okay. So talking about a RAG or retrieval augmented generation, this is actually a new method where introduced by a team of researchers. Where, for example, when we use a traditional large language model, they are trained on a large amount of textual data that is publicly available data, and they're trained on that part. If you want a specific chatbot or a specific system that works behind that works on large language model, but they have the information only that's available on public informations. So if we want a chatbot or a system that's very confidential to our private data or our specific company's private data, then in this case the chatbot will not work properly because the chatbot don't have the information of your own private data. So RAG is basically enhances this process by introducing external data to the system. So we can provide external information like a document or a vector database, and the large language model will take answer from this vector database and then passes this information to the chatbot. Normally the chatbot will only have the information from the large language model which is actually trained on. But when we using a retrieval augmented generation method, we will additionally adding external information that's maybe completely private or our own information. Then we will give the model access to this database or the document. So we will when we ask a question that's only relevant to this document, the chatbot will take the answer from this document and give us the output.
So like we'll have to create that special database.
Exactly.
Right.
So that's actually a kind of database, but that's not a normal database schema development, normal database development. We can just create many just load many documents, and we can input as how many types of chunks, or what are the number of chunks that we need to create. Just a simple step, then it will automatically create the vector database. But that vector database depends on the size of the document. If the document is very small, that we can use that as a context limit, we can use inside the context limit, then we don't need to create a vector database. But if that input is too much high, if that there are too much documents that we have, then we need to create a vector database so that it can hold all this information on the vector database. Then it will take the relevant information from this vector database and it will give output from this information. So that's actually a retrieval generation process. So it will retrieve from the database and give you the output.
Next, I think we could talk about AI agents. I think that is a pretty much new word that has very boomingly come up. Can you tell us what these AI agents are and how they affect the dynamic environment and how they make decisions?
Okay, so talking about AI agents, that's actually a normal system, but that controlled by a large language model. So large language model is actually the brain of a system, and they have some access to some we call as tools, where the tools is some external functions or APIs that will interact with the external world. So the large language model will make decisions upon the environment. For example, if we consider as a chatbot, so a user asking something about a leave policy or something like how many leaves that I have balanced, then the AI agent will understand the intent of the user question, and it will take a relevant API or a tool that will access the actual database, get the result from the database by calling this API and return back the user. So the AI agent is basically backed by a large language model. It will understand what the user is wanted, what the environment is actually, and take the relevant tools based on the user question. If he asking something another question, it will take the relevant other tools. So based on what the intent is actually, it will decide what need to do the next step. So all the step of these AI agents are basically goal driven. So we need to provide what's the goal of this agent. Then the agent will decide how to achieve this specific goal. So there are AI agents and agentic AI, which is exactly almost the same, but there are we can control how the system will work. AI agents can both this information, both this system will have the access to a large language model, which is actually the brain. There are some tools which is actually the action, what action need to take, and this with the help of these tools it will take the actions. So we can consider that as a human body, where the large language model is the brain of the system and our hands and legs are the tools actually. So if we need to take something from a table, then the agent will decide, okay, you can use the hand, then take the data. Like that, it will take the informations from the system.
If you look into these agentic AI or AI agents work just like how human beings work.
Exactly. So they can take the input as a text, they can hear us, they can take control of their camera or visions, they can process all this information same time, and it will give you an output like how we want to achieve this specific task. Then it will achieve that task and we will eat from that part.
What is your view on current state of large language models, and if you could give a comparison how it took over that GPT-2 and GPT-3?
So as I said earlier, the GPT 3.5 was almost a breakthrough on this large language model and Gen AI. So at first they just open source GPT-2, and then they completely closed every models, and there came of 3.5, 3.0 turbo for GPT-4, GPT-4 Vision. There are many models that they came up. Currently all those large language models are only known for multimodality. So previously they only have a unimodality. So they only take one input and they only process one input. Currently all of the model that's currently available will do multimodal information. It will process multimodality and will give you the output. So we can generally say that this is actually the top-notch model currently available, because every day there are new large language models are coming up. They are beating the just previous released models, and all of the models are currently top-notch. There are many models from OpenAI, there are models from Llama, Meta, and there are models from Cloud. There are many large language models available. We can use different models for different purposes. We can't say that currently this is a top-notch model is from OpenAI, but there are models that may come up tomorrow itself, which will beat all of this model. That's how the China's deep sea carbon model came up within a few days, and it will beat all these models. So we can't directly say this is actually the top-notch model, but we can expect there will be a mini model that will came up in next weeks or next month that will beat all these current models.
We know there is a buzz around that smaller, like more efficient models running on edge devices. What is your thought on that?
Okay, so actually we can say that the next main key evolve is actually based on edge devices. So edge devices, we can say there are IoT devices, mobile devices, all those devices that may we need to run all these large language models or small language models, where it will completely run upon on devices. So there will not be any connection on this cloud connection, or all those information processing, everything will be upon the system. So currently there is not actually a famous model that will run on edge devices, but there are coming up different models, but we can't say that there is a top-notch models currently available on that platform, but there are models that's coming up on different days that will run on devices or on Raspberry Pi or on smartphones. But it will came that maybe the next breakthrough on this area.
In a world where like AI has become, what could be the next stage of AI that you think?
So the next stage of AI is basically, as Jensen Huang said in an NVIDIA conference, which will be a physical AI. So currently we are living in an era of agentic AI, where the agents will control the software development part. So the next area is actually physical AI. So the robot will be the control of the future. So where agents have the full capability to control our emotions, our inputs. It will process all those different types of inputs, which is actually the multimodality of the agents. It will take its own decisions. It will take actual tools to achieve the specific task. All those software side brain is actually developed. So the next side of this development is actually that will give up to the hardware process. So all this software side brain will implement it to a hardware type system, which is actually the robot. Then robot will take up this next step, forward step. Where actually already there are many companies that will take this as an example. For example, in case of Tesla, Optimus, they are developing the robot. ChatGPT implemented Figure. There's a robot company which is developing the robot. Neon is another company which is developing a human-friendly robot. There are many robots are currently evolving. There are many robots already in the manufacturing plant that will do many continuous 24/7 works. So there are many robots are already developing, then they will implemented by the AI agents, which will control all these systems. So agent will be the main brain behind these robots. So the next main step or main evolution will be the physical AI or the robotics, which will complete the AI based robotics.
I think, Srihri, you have pretty much given a very good idea of now how AI has started and how AI is going through and how it would be in future. That brings us to an end of this TA Tech Leaders series. Thank you, Srihri, for joining us. Until next time, this is Malavika signing off from TA Tech Leaders series, where we explore ideas and expand on possibilities.